Hi there. Question 4. I make no apologies about having a line of best fit already there, because drawing that is horrendous. So 4A, complete the scatter diagram of J against T by plotting the last 2 points from the table above. So we've got to get those two in there. So 30 goes up to 25, which is into there. And then 20 to 27. 28, 27, just like that. Okay, happy with that. So maybe my regression line needs to change now that I've drawn that. That's fine. I'm okay with it. So an easy mark really for plotting those. Let's go to part B. It's appropriate to exclude 2 of the points when calculating the equation of the regression line of J on T. Identify the 2 points. So we're looking for a couple of outliers here and give reasons. So we've got one there. And we've got one there, and they do not fit the trend. So our 2 points are 10, 21, and then also, it's not 10, 21, it is 10, 21, 25, 38. And our reason is they do not fit the trend set out by the regression line. So they stand out. Right, excluding the 2 points you've identified, calculate the equation of the regression line. So 2 of the dots, 2 of the lines I was using, and the mark scheme disagrees with me, so hopefully it's going to start using some follow-throughs. Did I use this one? I'll use this one. So these are 2 coordinates that are on the line. This is quite nicely the y-intercept. And then 45, 19 is this last one here. So I've used those 2, although actually the regression line doesn't go through it. Should have probably used the first place, but it doesn't matter. So we're going to do our up divided by across. So 36 has gone to 19. 19 take away 36. And then 45 take away 0. That gives us negative 17 over 45, which is negative 0.3, and then the 7 recurs. So our equation is J equals 36, because that's the y-intercept, take away 0.37 recurring t. And if you've got something very close to negative 0.37 recurring, you're okay, because you're taking different points. You should take them from the regression line, really, and that's probably why I'm not quite equaling it. But if I could have done on the pen and paper, I'd have had my ruler between there and there, and I'd have drawn them across, because actually it's pretty good. It's a pretty good line. May need to be a little bit more with a more negative gradient, but I'm okay with it. Okay, last bit. Draw your regression line. Done that. Cheers. Work out the time that Alex should leave home in order to arrive at 8:30. Now, everything above was saying 7:30 was the start time. So basically, the journey time and the other time has to equal 60 in order for him not to be late. So let's look at this. So all of the positions where they add up to make 60, we've got one there, 35 to 25, and that would be that line there. So now I've got to use the ruler. I didn't want to do this live, but I'm going to have to do it now. So, I think a 45-degree angle is probably perfect on that. Would you believe it? Not quite perfect at all. There we go. Well, that's all right. I'm happy with that. I'm going to do it in red so it stands out. So that's my crossover point. Get rid of the ruler. Go back to purple. And then it's just this position here. So that's into there. That is 36, 37, 38 minutes. So 38 minutes. Now that means the journey time is going to be 22 minutes, meaning that he arrives there at 8:30. So T will equal 38 minutes. And I should get all the marks by drawing that onto the diagram. Now, again, your regression line is going to be slightly different, so you're going to get a little bit of leeway. I'm just going to go to the mark scheme, read that a little bit off for you. So, the mark scheme says 39 point something, so we're not super far away with 38. And then the last thing we need to do is the 7th. Oh, please write, come on. not writing for me. Now it is. So 7:30. Hello. It's decided to go. Let me see if I can click on it. Right, 7:30 a.m. plus that 38 minutes. That means 8:08 a.m. is when I'm telling him to leave. All right, that's question 4 done.